Have you ever considered what it might be like to live on land that is actively, visibly pulling itself apart? This is the reality of Iceland. It is a young land, geologically speaking, an island still being born, still stretching and growing. The ground beneath your feet in Iceland is not ancient and settled. It is new, dynamic, and restless. This constant movement shapes every aspect of the island, from its dramatic landscapes to the very spirit of its people. Iceland is a place where the Earth's raw power is on full display. You can see the evidence of this movement everywhere. Great cracks, or fissures, scar the land, some large enough to walk through, others small, subtle reminders of the tension below. Steam vents hiss from the ground, releasing the heat of the planet's core. Hot springs bubble up, offering warmth in a subarctic climate. Volcanoes, both active and dormant, dominate the skyline, their presence a constant reminder of the molten rock that lies just beneath the surface. This geological dynamism is not a subtle academic concept in Iceland. It is a tangible part of daily life. To understand why Iceland is so geologically active, we must look deep beneath the surface of our planet. The Earth's outer layer, known as the lithosphere, is not one solid piece. Instead, it is broken into several large and small segments called tectonic plates. Think of it like a giant cracked eggshell with these pieces constantly moving, albeit very slowly. These plates float on the semi-molten layer beneath them, the asthenosphere. Their movement is driven by convection currents within the Earth's mantle, similar to how water circulates in a boiling pot, but on a vastly larger and slower scale. These tectonic plates interact with each other at their boundaries in different ways. Some plates collide, pushing up mountain ranges like the Himalayas. This is called a convergent boundary. Other plates slide past each other, causing earthquakes along fault lines such as the San Andreas Fault in California. This is known as a transform boundary. And then, some plates move away from each other. This is called a divergent boundary. At these divergent boundaries, magma from the mantle rises to fill the gap, creating new crust. This is precisely what is happening beneath Iceland, making it a very special place. Iceland sits directly on top of one of these divergent plate boundaries. This boundary is known as the Mid-Atlantic Ridge. Iceland's unique geographical position means it is literally being torn in two. The western part of Iceland, including the capital city Reykjavik and the Reykjanes Peninsula, lies on the North American plate. The eastern part of the country, including areas like Vatnajökull Glacier and the East Fjords, rests on the Eurasian plate. This means that as you travel across Iceland, you are in a sense crossing from one continent to another. The line of separation, the Mid-Atlantic Ridge, runs right through the heart of the island, creating a zone of intense geological activity. The two tectonic plates, the North American and the Eurasian, are moving apart at an average rate of about 2 to 2.5 centimeters, about 1 inch per year. This might not sound like much, but over geological timescales, it adds up significantly. This constant, slow separation creates immense tension in the Earth's crust beneath Iceland. This tension is released through earthquakes and volcanic eruptions. The landscape is constantly being stretched, cracked, and reshaped by these powerful forces. The story of Iceland's creation is a story written in fire and rock. The island owes its very existence to volcanic activity, a direct consequence of its position on the Mid-Atlantic Ridge. As the North American and Eurasian tectonic plates pull apart, magma from the Earth's mantle rises to fill the gap. This molten rock or lava erupts onto the surface, cools and solidifies, gradually building up the landmass. Over millions of years, countless eruptions have layered lava upon lava, creating the island we see today. Iceland is, in essence, a huge pile of volcanic rock. This process of land formation is not a relic of the distant past, it is an ongoing phenomenon. Iceland is one of the most volcanically active regions in the world, with an eruption occurring on average every 4 to 5 years. There are over 130 volcanic mountains in Iceland, many of which are still active. These volcanoes come in various forms, from towering stratovolcanoes like Hekla and Eyjafjallajökull, whose 2010 eruption famously disrupted air travel, to extensive fissure systems that can produce vast floods of lava. Section 5. Water, ice and tremors, the ever-shaping forces. While volcanoes are the primary architects of Iceland's landmass, other powerful natural forces, also linked to its tectonic setting, continuously sculpt and reshape the island. Water, in its various forms, plays a crucial role, The geothermal heat generated by the underlying magma means that Iceland is rich in hot springs, geysers, and bubbling mud pools. These features are not just tourist attractions, they are manifestations of the immense energy simmering just beneath the surface. The most famous geyser, Strókr, erupts every few minutes, shooting a column of hot water and steam high into the air, a dramatic display of this geothermal power. Ice, too, has left an indelible mark on Iceland's landscape. Despite its volcanic heat, Iceland's northerly latitude means that large parts of the country are covered by glaciers. In fact, over 10% of Iceland is ice-capped. These massive rivers of ice have carved deep valleys and fjords over millennia, grinding down mountains and transporting vast amounts of rock and sediment. The interplay between volcanic activity and glaciers can be particularly dramatic, leading to events known as jökullaups, or glacial outburst floods, when subglacial volcanic eruptions melt vast quantities of ice, causing sudden and powerful floods. Section 6. Whispers from the Deep: Iceland's Geological Secrets. Beyond the well-known volcanoes and geysers, Iceland holds many lesser-known geological wonders, subtle whispers from the Earth's deep interior. Consider for instance the unique pseudo-craters found around Lake Mývatn in northern Iceland. These formations look like typical volcanic craters, but they were not formed by direct eruptions of lava from a magma conduit. Instead, they were created when hot, flowing lava moved over wet ground, such as a marsh or a shallow lake. The water beneath the lava instantly boiled, causing steam explosions that blasted through the lava, forming these distinctive crater-like shapes. The island's unique geology also supports fascinating ecosystems. Section 7. Thingvellir, a walk through continental drifting. There is perhaps no better place on Earth to witness the raw power of plate tectonics with your own eyes than Thingvellir National Park in Iceland. This remarkable site, a UNESCO World Heritage Area, is not only historically significant as the location of Iceland's ancient parliament, the Alþingi, founded in 930 AD, but it is also a geological marvel. Thingvellir is situated directly in the Rift Valley that marks the crest of the Mid-Atlantic Ridge, the boundary between the North American and Eurasian tectonic plates. Here, the effects of continental drift are strikingly visible. The most prominent feature at Thingvellir is the Almannagjá Fault, a massive canyon-like fissure that forms the eastern edge of the North American plate. Walking through Almannagjá, with its towering rock walls on one side, you are literally walking along the edge of a continent. On the other side of the valley, a few kilometers to the east, lies the edge of the Eurasian plate, marked by other fissures and faults. The valley floor between these two boundaries is a graben, a block of land that has subsided as the plates have pulled apart. This area is actively rifting, with the land sinking and spreading. Section 8. Journeys to the Edge, more geological hotspots. While Thingvellir offers a dramatic showcase of plate tectonics, many other locations across Iceland provide equally compelling evidence of the country's dynamic geology. The Reykjanes Peninsula in the southwest is another area where the Mid-Atlantic Ridge is exposed on land. Here, you can find the Bridge Between Continents, a small footbridge built across a fissure, symbolically linking the North American and Eurasian plates. The peninsula is a geothermal hotspot, characterized by steaming vents, bubbling mud pools, and vast rugged lava fields, including those from very recent eruptions. Further afield, regions like Krafla in northern Iceland offer a glimpse into active volcanic systems. Krafla is a caldera, a large volcanic depression, that has experienced numerous eruptions and rifting events, most notably, the Krafla fires between 1975 and 1984. This period saw repeated episodes of magma intrusion and fissure eruptions, dramatically altering the landscape. Visitors can walk through still warm lava fields, see steaming boreholes from geothermal power plants, and witness the raw power that continues to shape this area. Section 9. Nature's unfolding masterpiece, Iceland's dynamic beauty. Iceland stands as a profound testament to the immense and unceasing power of nature. It is a country on the move, a land constantly being remade by the colossal forces of plate tectonics. This restlessness is not a flaw, it is the very essence of Iceland's character, the source of its stark and breathtaking beauty. The volcanoes that scar its surface, the fissures that cleave its plains, and the geothermal energy that steams from its core are all part of a grand, ongoing geological drama. It is a drama that has been playing out for millions of years and will continue for millions more. The beauty born from this constant change is unique and deeply moving. It is a raw, elemental beauty, one that speaks of creation and destruction, of fire and ice. The vibrant green moss clinging to ancient lava fields, the ethereal blue of glacial ice caves, the dramatic plumes of erupting geysers, these are scenes that etch themselves into memory. This landscape is not static, it is alive, breathing, and evolving.